All right, we're going to do some more exponent graphs, exponential functions, and this time out what we're going to do is we're going to build upon what we had done in the previous videos, where it was just something like previously we would just look at basic exponential functions like this right here, where it was a number to the power of x, simply a growth or a decay function, and you basically produced either a growth curve or a decay curve, depending if your number b to the power of x was greater than 1 or if it was between 0 and 1. And we had the same y-intercept, the same horizontal asymptote, and all that kind of stuff. This time out, okay, we're going to take these graphs and we're going to translate them, reflect them, and stretch them, and turn them into variations of those graphs. And we have two examples that we're going to do today. Let's start off with example 1. And of course, anytime you have a transformation equation and you're asked to sketch the function, the very first thing you want to try to do is to make a mapping notation. So we're going to do that right now. But something about this, okay, you want to make sure that the number 3 does not appear into your mapping notation. Okay, the number 3 is not part of it because what we're doing is we're translating this basic graph of y is equal to 3 to the power of x. Okay, so what we're doing is we're taking this basic growth function that we looked at in the previous section, and we're going to do things to it. So because the 3, the base number, is part of the original function, okay, we're not going to put that in the mapping notation, but we will put everything else. And most of what we've already learned about mappings and transformations are still the same. Okay, so we have an exponential function. So the x parts are located in the middle of the equation. In this case right here, okay, it is an exponent x minus 4, which in the mapping notation will be x plus 4. So we have a horizontal translation of 4 units to the right. And then, of course, the outside parts do not change, the 2 and the 1. So we have a vertical stretch of 2 and a vertical translation of 1 unit up. No reflections in this graph right here. So you might say, okay, well, what about table of values? Okay, what points are we plugging in? Well, that's going to be different every single time. It all depends on which type of exponential function you are translating. So in this case, okay, the number in the brackets in the equation is a 3. So we are translating the y is equal to 3 to the x graph. So what we're going to do is we're going to make a table of values with 5 points. Regardless of what number it is that is to the power of x, we will use x values from -2 to +2. That gives you like the center, the middle of the graph originally. And of course, what we'll do here is we're not putting these into the mapping notation just yet because I need to get my corresponding y coordinates. So I just put it into the y is equal to 3 to the power of x equation. And away we go. 3 squared is 9. 3 to the 1 is 3. 3 to the 0, or anything to the 0, is a 1. 3 to the -1, once again, that's really 1 over 3 to the +1, which is 1/3. And again, feel free to use decimal numbers because when we plug into mapping notations, maybe that's a little bit easier. So feel free to do that. And then for the same reason, okay, this is a 1 over 9, 3 to the -2, or approximately 0.11. Okay, now we're ready to put into a mapping notation. So what I'm going to do here is take these x and y values, plug them into the x and y parts of my mapping notation as you've already seen before in previous units. And we're going to wind up with something like this right here. Okay, so if I plug in each of these values, you're going to get something to this effect right here. And this is what we have. Now I use decimal numbers for my new table of values. You can decide for yourself if we're going to do that or not. And if I sketch these points here, this is going to be a very basic sketch here. It doesn't look like I have a whole lot of room. One thing you're going to notice right here is that we're not going to get all of the points on the graph. Okay, this 619 point, once again, okay, Maybe one or more of your points are going to be too large to get on your graph, and that's fine. But one thing I noticed that I have here is I have these points right here. As I graph each one, you're going to notice that the graph goes something like this right here. And that's correct. Okay, that's exactly what's happening. Okay, so that is a regular growth curve, but moved to the right 4 units, up 1 unit, a vertical stretch of 2, which is a little harder to see. And if we go into Desmos, okay, we can plot this graph right here. And what I have in red is I have the graph done on Desmos, and we now have a new function. Let's try to take a look at what the horizontal asymptote and the x-intercept could be. Well, actually, from this graph, you don't see an x-intercept at all. We're going to deal with y-intercepts only. Okay, so let's calculate those. So what we have here, okay, is now that we have our graph, let's take a look at doing a y-intercept. Y-intercept, of course, is plugging in 0 for x. No problems there. Go into our equation, plug in 0 for x, use the order of operations. So you're going to end up with 3 to the negative 4, which of course is really 1 over 3 to the positive 4, or 81. Use some decimal numbers for these, and you'll quickly see that your y-intercept for this is going to be 1.025 approximately. Okay, which looks about right on this graph. It's not very accurate. What about a horizontal asymptote? Well, let's just say that in general, okay, for all transformations of exponential functions, you can get your horizontal asymptote from your vertical translation. We just want to make sure that we're writing it as the equation of a horizontal line, so we should write it as y is equal to positive 1. And you might say to yourself, well, why is a vertical translation a horizontal asymptote? Well, the reason is because even though you have a horizontal line, you're shifting it up or down. Okay, so you're translating this horizontal line, you're translating it vertically, up or down. So it was originally at 0. So if you shifted your graph up 1, then the asymptote shifts along with it. And once you have your horizontal asymptote and you have your graph drawn, all right, we can get our domain and range. First of all, domains for all exponential functions are all real numbers, so no thought required for that one. For the range, we're going to say it's from 1 to infinity with a round bracket around 1 because it doesn't actually touch 1. We know that the graph is above the horizontal asymptote, so it's above the line of y is equal to 1.